The question we want to answer today is how can we determine the acceleration on a frictionless ramp? Conceptually, we can see that if the angle of our ramp is 0 degrees, the acceleration will likewise be 0 meters per second. If we continue this thought experiment and we rotate our ramp to 90 degrees, we can see that our acceleration will be g, or negative 9.8 meters per second. The thought experiment takes another turn when we go to some angle theta between 0 and 90 degrees, in which we ask, what is the acceleration? If we begin a graph of our angle versus our acceleration, we can see that we have two data points, 0 degrees and 0 acceleration, 90 degrees and negative 9.8, or g. Please pause the video and predict what the line, or how will you connect the 2 points. It's been my experience that most students will connect the line, or the 2 points, with a linear line. However, if we continue our thought experiment and continue to rotate our ramp to 180 degrees, we will notice that our acceleration once again returns to 0 degrees. If we continue with these linear lines, we'll see that we get a sawtooth pattern which does not represent the world around us. If we, however, use a sine curve, we will see that we get a repeating pattern from 0 to 180 to 360 degrees. If we delve a little bit deeper into the analytics, we can see where this relationship comes from. From our diagram above, we have the acceleration of gravity acting downward, and we have the acceleration of the cart, A sub c, down the ramp. If we add one more vector and then clean up the lines that we do not need, we can see that we have two triangles. The question is, are they similar? We can see that we have a 90-degree angle in the black triangle, and in the multicolored triangle with G, A sub c, and the blue, we have another 90-degree angle. If we label these two angles theta, the question is, are they equal? Using some simple geometry, we know that the interior of a triangle needs to be summed to 180 degrees. So therefore, the green angle needs to be 90 minus theta. The brown angle also needs to be 90 minus theta if they are equal. We can see that the two red lines are parallel, therefore making the brown and green angles equal. If angle 1 equals angle 2, which equals angle 90 degrees minus theta, we can then determine that theta 1 equals theta 2. Now, using our simple trigonometric ratios, we can determine the acceleration of the cart. If I know that sine theta is equal to the opposite over the hypotenuse, I can simply substitute in A sub c for the opposite and g for the hypotenuse. Rearranging, I get g sine theta equals A sub c. Returning to our original problem, we can now see if we set our theta equal to 20 degrees, we can now determine the acceleration of the cart. A sub c equals g sine theta, substituting in, A sub c equals negative 9.8 sine 20, then making sure that your calculator is in degrees, we can calculate and we should see that the acceleration of the cart is negative 3.35 meters per second squared. The negative simply referring to it being in a downward direction. Thank you, and if you have any questions, please leave them in the comments below.